Good afternoon. My name is Jeff Bedrosian. I'm a biologist with U.S. Fish and Wildlife Service. I want to start out today just recognizing the enormous effort of this group of the Sagebrush Conservation Design. Thank you for including me in this, and also recognize my co-authors. When you get a chance to work with your heroes, do it, and I'm very thankful for your support and guidance. Thank you. Today I'm going to talk about averted loss through preventing cropland conversion. But I want to back up and show a slide that you've seen in other talks, kind of looking at the sagebrush biome in context. We're looking at global human modification from Dave Theobald et al. And I want you to focus in on that sagebrush biome. Here in this color ramp, the brighter the colors, the more human modification of the landscape, including things like croplands. And you see this predominantly dark area of the sagebrush biome. Pivot over to the global map, and that's more similar to areas of desert, boreal forest, and taiga. This is a unique situation in temperate northern climates that we find ourselves in, where we can avert a change far ahead of the grasslands and other heavily altered systems. But that's not to say that we don't have threats. We've heard a lot today about invasive annual grasses and conifers, these things that have been growing. But today we're going to talk about the wholesale loss of cropland conversion. We sought out to put forward the first biome scale assessment of cropland conversion risk to sagebrush rangelands. And we're going to step through this in kind of three different temporal periods. First, we're going to look at the past. We want to scale the problem. What area of sagebrush has already been tilled? And I should say I'm going to use tillage, cultivation. These are all cultivated croplands that we're talking about today. Question two, can we future forecast? Can we map and identify where the highest quality sagebrush communities are most at risk to future tilled agriculture so that we know where to act? And then third, if we do act, how effective are those conservation actions? Can we estimate the ecological impact of easements and similar land protections to their surrounding landscape? Now we can get into some map time, so I want to give you a little bit of a chance to get acclimated. I know it's a little dark in here, but we're going to look at past loss and current extent kind of all in one map. In my watermelon color ramp here, focus on the pink purpley kind of part of the watermelon, and this is the footprint of existing croplands summarized from land cover data sets over the last 2 decades. But we know that a lot of that conversion happened prior to the last 2 decades. So how do you estimate what the impact was before our remote sensing modern window? For that, I used a surrogate of the greater sage grouse and published estimates of the current versus pre-settlement range for the greater sage grouse, a known sagebrush obligate. So there in the dark black outline, we have the pre-settlement range of the greater sage grouse, and shaded into sort of a dark green here is our current range. Look at how much pink is in the pre-settlement range of the great sage grouse. That's a massive area. And so it's not exact, but I'm going to use that to sort of estimate how much sagebrush was lost before we started measuring with remote satellites. And to put in context the numbers here, this is a heavily unaltered landscape globally, 4.3% cropland conversion across the biome. But that's the wall-to-wall biome. If we zoom into our sagebrush conservation design, we notably masked out croplands from that sagebrush conservation design. So read that 1% of conversion as being pretty much zero. It's kind of edge effects around the modeling frame of croplands that were masked but are now impeding the ecological function nearby. But look at the twofold change between the pre-settlement range of the sage grouse and the current range. That loss is almost 29 million acres of cropland conversion that extirpated the greater sage grouse from formerly sagebrush rangelands. In total, that's the size of the state of Ohio. So that pink area is an Ohio's worth of sagebrush that we have lost in the past to cropland conversion. And so I scale that to say, we recognize from the work of others in this session that in the current time frame, cultivation rates have slowed. We're looking at about 3% of the loss of sagebrush rangelands in the last 20 years has come from cropland conversion and other types of human modification. But we can see how big that impact has been, and we know there are uncertain futures ahead. Now that we've characterized the past, let's look towards the future. This is a risk modeling framework, or the matrix, as we nerdily like to call it, and you've seen a few other of these similar color ramps today. Across the x-axis, we have 3 categories of sagebrush ecological integrity. Coming down the y-axis, we have classified levels of threat, and in this case, it's risk of cropland conversion through a crop suitability model. We can then map and tabulate all of those areas in unique categories, and I'll highlight the yellow and oranges where we would recommend as a conservation measure to protect, and the relative priority of protecting those lands based on the relative value of those sagebrush habitats ecologically and the chance that it's going to get, or the probability that it's going to get converted. And just as a quick comparison, for folks that did their homework prior to the session, in the SCD we had similar risk matrices where we modeled human development, conifer, and invasive annual grasses. And I just wanted to highlight that they're similar, but there is a little bit of a difference taking into account the unique nature of conversion as wholesale loss and the value of adjacency. I won't belabor the point on SCI. I think that's been thoroughly covered, but to say that this was our mapping frame, we used the SCD as our map unit, and so that includes the same non-rangelands map. We are going to confine our study to the same space. As a measure of future cropland risk of conversion, we used the cropland suitability model originally developed by Smith and colleagues for a portion of the sagebrush range, where they subsequently continued that modeling process and built a wall-to-wall crop suitability model for CONUS at the county level. So this takes into account things like water availability, soils, and gave us complete coverage across the biome and kind of a first look at that compared to other studies. When you do the fancy trick of raster math, of adding 1 plus 10, and et cetera, this is the map you get. But the folks that work in this biome should have alarm bells going off, right? Clearly, large portions of this area are not available for cropland conversion due to land tenure, because you're not going to convert BLM lands, and especially other protected lands, to cropland. So it is important to use the protected area database to restrict us only to private and unprotected lands, and we cut that map down quite a bit. We lose about 60% of the area that was not available for cropland conversion, and now we are much more highly targeted to only 42% of that original SCD area. And I understand it might not show great here in the room, but what we're looking for are those yellow, orange, and red hotspots popping up on the map, now only in those areas where we would target where we can work. And we, of course, tabulated the areas and relative proportions for each relevant category. And while we can see areas of high cropland conversion risk in every state in the biome, it should be readily apparent that the greatest areas and highest concentrations and clusters of risk are occurring on the eastern side of the biome, where the sagebrush rangelands start to transition into the grasslands of the Great Plains, which of course have already seen tremendous loss to cropland conversion. This is what that looks like. Zooming into a landscape here, you can see Fort Peck and Glasgow north of the Missouri River, and we can see these aggregations of our red pixels kind of highlighting lands that are of high quality sagebrush rangelands and then most at risk. These are the places we want to work. So we've evaluated risk in the past. We've put together a view of that risk going forward in the future, but we wanted to evaluate our predictions and also evaluate conservation outcomes. So Dave Noggle teed this up for me perfectly. We found a case study area in north central Montana. This is Blaine, Phillips, and Valley counties. It's an area, I believe, actually close to the size of the state of Maryland. So we are in a small part of the sagebrush biome, but a big part of the world from this New Yorker's perspective. And why we wanted to zoom in here is that we wanted to highlight conservation success. How do we actually win in this system? And it takes collaborative partnerships and sustained cultural will. So I really want to highlight the efforts of the Rancher Stewardship Alliance and the Nature Conservancy that have been working in these landscapes for decades to build what we see here mapped in red as a saturated, I believe is the word was used earlier, but concentrations of easements that really anchor the landscapes. And we're going to measure how that happened. Folks that have worked in easement acquisition may be familiar with the LCC soil classes derived from Surgo. These are often used as a surrogate for crop suitability. And so lower soil classes on the left side of the diagram in greens are presumed to be better for croplands. On the right, in the oranges and reds, are higher value soils presumed to be lower quality for cultivation. And so using this surrogate can be complicated because turns out soils overlap one another, they're challenging to map. And we wanted to evaluate, well, how well would that work to predict cropland history, which if you remember from the watermelon slide map, we already have a map of cropland history to apply to the area. And it works okay. This is a monotonically decreasing pattern, as you would expect, where the most highest proportion of soils that had a cropland history were in the 3s and 4s. But to take a different look at how much of those black bars in the 6s and 7s did have a cropland history. It's not insignificant. And in fact, if you add up those bars, there was more cropland history on soils characterized as a 6 and a 7 as in soil class 4. And so I emphasize this just to make the point that lower quality soils have been cultivated. We know that they have value to wildlife species, and they're occurring in contiguous blocks. And so perhaps the soil data alone are not quite giving us the best picture on where easements are going to give us conservation value. Promise this is my busiest figure. You'll make it through it. All right, you've seen worse today. But now let's evaluate our approach. Let's take the Smith and colleagues cultivation crop suitability model and test it in the study area versus our crop history. And I do need to explain a modeling term from resource selection function evaluations, area adjusted frequency. That's essentially a fancy ratio and a way of recognizing that these model bins in equal intervals of 10 bins here, they don't occur in the same area in the landscape, right? So if something's very rare, you wouldn't expect it to occur a lot. And so the ratio accounts for that. So that's AAF. We see here in the model that any one of these bins above the dashed line at 1 would then occur more than you would expect under a null hypothesis of a random distribution. And we're monotonically increasing to the right. So it's a perfect rank order correlation. Crop suitability values that were 0.5 or higher were more likely than not to have a cropland history. And that top bin was 20 times more likely than random. You can also compare among bins. So that top bin was 40 times more likely to have a cropland history than, for example, the 0.5 value on the third bin. So this is a very strong predictive pattern, and we think is a much stronger predictor of cropland history and of future cropland than just soils data alone. I believe my colleagues have well demonstrated the value of SEI. I hope we've demonstrated the value of cropland suitability. So we have a strong predictive model. What happens if we don't take action? So now we're going to do kind of a thought experiment to ask the question, what would happen to SEI if those easements had been tilled? So here we're going to take that red on the map and in your mind, just plow it down, turn it into cultivated crops, wheat, etc., and then rerun the SEI model. I'll step through how that works kind of layer by layer. Here's our case study area. We're going to be back kind of north of Charles M. Russell National Wildlife Refuge, north central Montana. And here's our SEI values, really strong mix of core and growth areas. Here in our black outlines, this is our concentration of easements on the landscape, most but not all of which are on sagebrush rangelands. And now in that orange or yellow color or red, you can see what happens if they were cultivated. All of that is lost sagebrush rangeland, and then using the same methods from Bill Sparklin and colleagues, we kind of track those colors as it goes from core to growth, growth to other, core to other, being the red. But to really emphasize what those easements are doing, let's subtract those out of the map. So now you see blank spots where those easements are, because we would have masked those out of the model in the first place. And the existing yellows and reds show where core was lost. And 80% of that is on adjacent lands, primarily BLM lands. And so this is for the first time sort of estimating what are we getting for our easements. And I would argue here that we're getting more than just the easement footprint. we're getting ecological anchors that are sustaining ecological function, structural and functional connectivity at scales beyond the footprint of the land itself. If we quantify that, compared to the core areas that were on those easements, we've actually sustained ecological integrity at 3.6 times their size. I consider that a pretty good bang for the buck in conservation ecology. I also highlight that 80% of that benefit was on public lands, BLM grazing lands. And so we say cows, not plows, because this is really important to sustaining the ranching agriculture, the ranching lifestyle in these communities on those public lands that are embedded in this landscape. I'll borrow a phrase from Wallace Stegner and other colleagues here in the audience that turned me on to this. We're working in a geography of hope, and those geographies are few in today's society. The sagebrush biome is largely untilled and undeveloped, and we have an opportunity in our generation to avert that loss with proactive, targeted conservation. But hope is not enough. We need the change. And so that's where the action comes in. And our risk model, along with targeted models that you're going to hear next on conifers, invasive annual grasses, is part of a holistic view of taking action in the right places at the right time to make that change. But we've also shown action doesn't always mean success, but it has in places where people have concentrated that effort and saturated the landscape at a scale that matters, showing that easements in particular here can avert larger scale ecosystem loss. We think that this private lands conservation and the multiplicative benefit it shows really anchors these landscapes. And we want to emphasize that all soil types have value. And by using the core area approach, we can be more strategic, more effective, and avert loss before it happens. Thank you.